Alright, so here's example 2. It says completely simplify each radical, assume all variables represent positive values. We have to simplify the square root of x to the 11th. Okay. Once again, I could write out 11x factors and circle groups of 2 identical factors since I have a square root. Okay. But it's a little faster to simply say, all right, I have 11x factors. Let me go ahead and break that into groups of 2. Well, 2 goes into 11 5 times, but that leaves you with a remainder of 1. What that tells you is you're going to have 5x factors on the outside of your root, which is an x to the 5th, and you're going to have 1x factor remaining inside your root. Okay, so these are outside, these are inside. Remainder, remaining inside. So let's go ahead and write the overall result. When all is said and done, we end up with the square root of x to the 11th equaling x to the 5th out of the root times x to the 1st inside the root still. I won't even write the exponent since x to the 1st equals x. That's it. That's as simple as it gets. Right? There are no more pairs inside the square root for me to break down, so this is my simplified form. Okay, so part B gives us a fairly monster square root to simplify here. Right? But remember, we're going to treat each variable separately and also treat the coefficient separately. Right? So to help simplify the problem a little bit, let's consider the 3 things we have going on. We have the square root of 18. We have the square root of a to the 9th. And we have the square root of b to the 16th. Right? For the square root of 18, we're going to factor the 18 down using our factor tree. And then we know any pair of factors comes out of the square root. So this pair of 3's is going to come out as a single 3. And then any remaining factors stay in. So for the square root of 18, we're going to get a 3 outside with a 2 remaining inside. Let's handle the square root of a to the 9th next. We have 9 factors of a, and because it's a square root, we want to break them into groups of 2. So we divide 2 into 9. 2 goes into 9 4 times with a remainder of 1. So this tells me that I have an a to the 4th outside, right? 4 factors of a outside of my radical because of my 4 groups. And then I also have 1 a factor left inside. So in the end, the square root of a to the 9th is going to contribute an a to the 4th outside and a single a left inside. As for this square root of b to the 16th, it's a similar idea. We have 16 factors of b underneath our root. We need to divide them into groups of 2. 2 goes into 16 8 times with no remainder. So that tells me that I'm going to have a b to the 8th outside, right? 8 factors of b outside, and then no factors of b remaining inside. So the square root of b to the 16th contributes a b to the 8th outside the radical. So if we write overall, what we get when we simplify this monster radical expression, it's going to look like this. Square root of 18, a to the 9th, b to the 16th is going to be equal to the 18 gives me a 3 on the outside. The a to the 9th gives me an a to the 4th on the outside. And the b to the 16th gives me a b to the 8th on the outside of the radical. So these three factors need to go outside the radical. But then I still have two factors inside the radical, 2a. So I have to write square root of 2a. So that's my simplified form, 3a to the 4th, b to the 8th, times the square root of 2a. Okay, here's part C. We have another monster radical expression to simplify. This time it happens to be a cube root. The first thing we should really do is consider each of the variables and the coefficients separately. So I'm going to think about this as the cube root of negative 192, and then I'm also going to have to consider the cube root of x to the 11th, and then I also have the cube root of y cubed, and then finally I have the cube root of z. Right, so each of these has to be dealt with separately. The cube root of negative 192, remember when you take the cube root or an odd root of a negative number, the negative comes outside of the root. So to help simplify this negative, since it's an odd index, since it's an odd root, we're going to pull the negative out. If this were an even root, then this would not be a real number and we couldn't simplify this. Okay? But it's an odd root, so the negative comes out. Now we have to factor down 192. So let me write my factor tree for 192. Okay, so there's the factor tree for 192. Since we're dealing with cube roots, we have to go ahead and circle groups of 3. So here's 3 2's. Here's another 3 2's. And then there's still a 3 left on the inside. So we'll get a 2 out from this group, we'll get another 2 out from this group, and then this 3 remains inside. Which means altogether our cube root of negative 192 is going to equal negative 2 times 2 times the cube root of 3. Right, so this 2 times 2 becomes a 4 outside, this 3 stays inside, and the negative comes out as well. So that's the first part of our simplification. Now we move on and look at our variables. The cube root of x to the 11th means I have to take 11 x's and break them into groups of 3. 3 goes into 11 3 times, with a remainder of 2, which means altogether I have an x cubed outside, and I have an x squared inside. So let's write what we have all together here. The cube root of x to the 11th is going to give me x to the cubed outside of the radical, and then inside of a cube root there's an x squared left over. Alright, now we have to move on to the cube root of y cubed. We have 3 y's that we need to break into groups of 3. 3 goes into 3 one time with no remainder, which means that altogether we have a single y outside and no y's left inside the radical. So my cube root of y cubed is going to give me just y. Lastly, the cube root of z actually cannot be broken down any further, because if you try to break one z, right, since there's only one z factor inside, if you try to break that into a group of 3, you see that 3 doesn't go in. You can't break one thing into a group of 3. So there's only a remainder, which means there's going to be still one z remaining inside. And now let's look at all of our simplifications. We see that for the z variable, we couldn't make any simplification at all. Okay. For the y variable, we simplified to just a y on the outside. For the x variable, we simplified to x cubed, cube root of x squared. And then for our coefficient, we simplified to -4 cube root of 3. Which means that we can now write our overall simplified form of this monster cube root. Right? It's going to become -4 x cubed y on the outside and then on the inside of a cube root we have a 3 left, we have an x squared left, and we have a z left. So I'm going to write 3x squared z. So this is our simplified version of this disastrous cube root. Whew, that was a lot of work.